Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Izzy Lawrence.
Hello and welcome to Terrible Lizards. It is the best episode of the entire series, for it is the questions episode, where we answer your questions. When we say we, Dave answers your questions.
And when we say answers, we mean sort of talks around the subject because he doesn't necessarily know.
Well, we acknowledge here that Dave is what we call fallible. He does make errors. So we've got a few corrections to get to before we get to the lovely questions. So what did you get wrong, Dave, this series so far?
So far less this series than the first one, though possibly more than series 2. So the one that 1,000 people pointed out almost literally is, so when we talked about really big stuff in the sea, I mentioned this marine reptile from Svalbard called, inverted commas, Predator, or Spitsbergen, called Predator X. And I believe I said it was a mosasaur. It's not a mosasaur, it's a pliosaur.
That's ridiculous.
I know, it's an awful, terrible error that I misremembered a group I don't work on that was on TV 20 years ago.
Well, you're a terrible man. You're a terrible man. So the pliosaurs are the ones that are like the Loch Ness Monster, is that right?
Pliosaurs and plesiosaurs are a pretty closely related group. The plesiosaurs are the very long-necked ones. The pliosaurs usually don't have much of a neck, and it's just a big head bolted onto a body with little flippers. Well, big flippers, actually.
Aren't the plesiosaurs way more polite?
And the pliosaurs, very useful for extracting teeth. Okay, so what else? What else did you get wrong, Dave?
So the other one was we talked about this old idea that Diplodocus had this kind of sprawling lizard-like posture with the arms out sideways. And I referenced an illustration by an artist called John Sibbick that showed this like giant furrow in the ground. And someone commented that although I was referencing that image as a point that this is an obvious reason that they couldn't possibly walk like that because this is what you'd get. Apparently I said that paleontologists were actually looking for those furrows, which is not true at all, and I presumably just made up on the spot or completely misremembered.
What was great about that was on Reddit that we found that out.
Yeah.
Not only Twitter, not only Patreon, not only Facebook, but also, we're so famous.
Yeah, with our tiny listenership. And then the other thing that cropped up wasn't really a mistake, but we talked about possibility of crocodiles changing colour. And I said it had been done in, I think I said it was the New Guinean crocodile. It is actually several crocodiles from that region, including the saltwater crocodile and a thing called Tobistoma, known as the false gharial, but apparently the New Guinean croc isn't actually on that list. But there are now 6 different species where this has been shown. So it is a bit more widespread in crocodilians, though currently not known in alligators, that they can change colour at least a little bit, which is really quite cool.
Which is ironic because you can see them later. Okay, we're recording this in the morning and I haven't had enough coffee, so this is going to be brilliant. Is that all the corrections?
Yeah, that's all the ones I've written down.
Okay, fair enough. I don't believe you that could be all of them. So we've asked our patrons and members of the general, less juicy public to write in their questions, and these are some of the questions which have come up. We'll try and get through as many as possible. We have this question from Glenn. Now, Glenn is a special sort of man, because he says, I've been trying to find out a more clear answer as to the flexibility or stiffness of dinosaur tails. I have often read that the interlocking of the caudal vertebrae meant that many dinosaurs, such as Dromaeosaurus, had very stiff, inflexible tails that could only bend at the base. Yet the famous fighting dinosaur fossil includes a velociraptor, which appears to have an articulated tail that is clearly in a curved position. One source suggests they could bend their tails laterally and not dorsoventrally.
Dorsoventrally, so in other words, up and down.
Yeah, exactly, like a dorsal fin. I can read them in my head, but out loud it's hard. I've encountered similar claims to stiff tails among sauropods, although remember descriptions from decades ago of a whip-like sauropod tails that could be used as weapons that were so fast at the tip that they'd break the sound barrier. I even read one article that suggested some sauropod species have stiff-tailed and flexible-tailed individuals within the species, and that there might be a gender difference. I'm a bit dubious of this. I was hoping you could shed some light on the current thinking on how dinosaurs could hold and bend their tails.
Yes, I can hopefully shed some light. Oh, there's a lot to unpack. That's an episode we've pretty much just got covered there. So in an attempt to get through other questions as well, I think the fundamental issue here is one about ambiguous terms, which is something that drives me nuts. So people go, oh, it's a very stiff tail. And it's like, well, titanium rods are extraordinarily stiff and you need some kind of crane or something to bend it the tiniest bit. Those plastic rulers that we all have at school are actually pretty stiff, but if you give them a waggle, they're quite flexible. So, it's a relative term saying that something is stiff. And therefore, if people aren't too specific about it, I think that's when confusion reigns. So Dromaeosaurs, I'm not sure if we talked about this before, but Velociraptor and Deinonychus and Dromaeosaurus and their relatives have this bundle of little bony rods running down the length of the tail that bind like a whole bunch of strands of spaghetti all lining together around the main vertebrae. These will inevitably stiffen the tail. You can't put bony rods along a tail and not make it stiffer than the animals around it. That doesn't mean it couldn't flex. And as you said in the question, yeah, we've got several Dromaeosaur fossils that clearly show the tail bent. So it clearly is capable of flexion. And those bony rods, they are, I liken them to dry spaghetti. They're pretty stiff, but that doesn't mean they don't have a fair amount of bend in them without breaking if you put a bit of energy in. So yeah, Dromaeosaurs absolutely have much stiffer tails than other dinosaurs. That doesn't mean it's just like a broom handle and it just won't bend one iota. Though they're definitely more flexible at the base of the tail because you don't have those rods there. And actually you want to be able to swing the tail around as a counterbalance to keep you balanced.
So if we compare them to something like a cat tail, because a cat tail can be very stiff.
Nothing like that. No. Yeah, but
they can't wrap it around themselves.
Right, at rest that tail is very, very flexible, whereas at rest this tail would be very, very stiff. So yeah, much more like something like a kangaroo. If you look at them, they flex at the base, and when the end will curl a bit, but a kangaroo's tail pretty much just sticks out. So yeah, more kangaroo than cat. As for sauropods, I think people think their tails are generally stiffened simply because they usually are very long indeed. And if you're going to hold that off the ground, and of course you've got to remember there's lots of big muscles on the tail that connect to the backs of the legs to help it move, that is going to hold it up and off the ground. You generally want at least a bit of tail stiffness. So I've literally just published a paper like a couple of weeks ago talking about tail flexibility and tail stiffness, among other things. This is very well timed. But because you've got these big muscles in the tail connected to the legs, you want a stiff tail because what you're doing, of course, is if you contract the muscles in that big block of muscle, you want it to be pulling the leg back and pushing you forward. What you don't want all that energy to be doing is dissipating into bending the tail. So you do generally want a fairly stiff structure there. So the bases of the tail, when I say base, I mean actually the first third to the first half, is going to have this muscle attachment and therefore is going to be probably relatively stiff compared to the end of the tail where that's not going on and it can be more flexible. And we do generally see a pattern of that, which is in my paper, so worth having a look at.
So does that mean that it's only the very, very end of the Diplodocus tail that could get the sound crack barrier, and it could do it from the tip? It could just go like clicking your fingers.
Diplodocus has a ludicrously long tail. I mean, it's not just a very big dinosaur, but it's like 2/3 of its length is tail. And this is an animal with a giant neck and a big body. And so Diplodocus is a bit of an exception where I'm talking about the first third to the first half. I mean, like the first quarter or less, because there's just so much tail. It's got at least 80 vertebrae in the tail, and a more normal number for dinosaurs is like 35 to 40. So it's got twice as many bones in the tail. And a lot of them are very long and thin and kind of like those fat permanent markers that you get to write on whiteboards in schools. They're shaped like that. They're about that length and about that width. And there's just acres of them going on forever. And yeah, so much like a whip, the idea if you flex the tail one way and then back the other suddenly, you'll get this propagation of energy. You got loads and loads and loads of little joints, and that thing will flick and accelerate because you've got more energy going into less mass. And in theory, at least, which is a very critical point because this is a calculation done on a computer, it can exceed the sound barrier and produce a crack. Whether it did or not, and whether that was actually used for anything like fighting off predators or warning them, no one has the faintest clue.
Do you reckon, though, that a bored Diplodocus could do the equivalent of cracking its knuckles with its tail and just go pop, 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 pop? And how long would that pop sound go?
No idea and no idea.
Okay, well, we've got another question for you. We've got another question. Well done. That's a good, nice long tale about tails. Matt Potter. Hello, very much enjoying the podcast. Of course you are, Matt. Of course you are. I wondered if you could recommend a good book that shows accurate pictures of dinosaurs that we're discussing. Some I know, but some I've no mental picture of. And he also very much enjoyed Tyrannosaur Chronicles.
Excellent. Yeah. There's a couple. So the two I usually recommend. So the first one is it's got some awful long-winded title like The Complete Encyclopedia of Dinosaurs for Dinosaur Lovers of All Ages, by Tom Holtz and illustrated by Louise Ray. So sometimes it's listed as Holtz, sometimes it's listed as Holtz and Ray. That's a fair bit dated now. It's 10, 12 years old, but it is still in print, and it is very, very good. And that's particularly useful because it does more or less go section by section. So it's like, here's this group of dinosaurs. Here's the ankylosaurs and stegosaurs. Now here's a section on ankylosaurs. Here's a section on stegosaurs. Next group, here's a section, here's a section. And so from the kind of thing you're asking about, it's excellent because it just goes group by group by group by group by group. It's outdated only really in the sense that obviously we've discovered loads of new dinosaurs since then, but it never attempted to be truly comprehensive in the terms of listing every single individual species. And these individual sections are just, here's an overview of what this group is generally like. And obviously that information hasn't really dated at all. And so I think it's still excellent for this kind of general introduction to all of the different dinosaur groups.
It's not so much a general introduction of all the different dinosaur groups that we want, Dave. It is, what is Dave banging on about? That is the name of the book that we need.
But it's got all those groups in, and so you can flick through and find your picture and read, a couple of pages on alvarezsaurs or thyrophorians or heterodontosaurs or whatever it is. The other one I'd recommend, and I can't remember the exact title of it, but it's by Darren Nation, Paul Barrett, and it's produced by the Natural History Museum in London.
It's called Dinosaurs. It's on my bookshelf.
It's just called Dinosaurs. Yes, I can see it over your shoulder. But it's got some slightly longer title, I think. That's just had a reissue, and so there's an updated second or even third edition. That is super up to date and super detailed, and it's very, very good. But it doesn't go group by group by group. It's more about here's a chapter on physiology and here's a chapter on distribution and stuff. So they're different dinosaur books trying to do different things. I think the Naish and Barrett is the most up-to-date and kind of comprehensive, I want to learn everything about dinosaurs book available. And I think the Holtz is the best, here's all the different groups of dinosaur book. So one or the other or both should really take care of your needs.
Excellent. Now, we have from, I believe, David Bax is one of our patrons. His name is actually David Bax, bracket, Spino Breaker, close brackets.
That sounds painful.
So this is an interesting question. What fake dinosaur, either made up in part, a combination of multiple different fossils first thought to be a thing, or a reconstruction of an extinct animal that's now laughably wrong, would you actually like to be a real thing? So I can't say Indominus Rex, can I?
No. So the one that strikes me, I'm going to forget the exact details, but it doesn't matter too much. So when some of the initial discoveries of Tyrannosaurus Rex material were made, and it was just, some fragments of bone and some teeth. Often when we dig up dinosaur quarries, of course, what we're doing is we find a few bones and we dig and we see what else is in there. And of course, because these are almost inevitably deposits in rivers and lakes and stuff like that, other bones and teeth and bits will wash in. You actually don't usually dig up just a dinosaur. There's some fish scales or a bit of crocodile arm or a random bone from a lizard or some shells or plant material and other bits mixed in there as well. And of course, if you're going back to the earliest 1900s, we didn't have dozens of skeletons of all the different species. We didn't necessarily know what everything looked like. And so there were some mistakes made where bits of two dinosaurs coming out of a single quarry got mixed together until later we realised, it doesn't have two weird kinds of teeth. It's got these kinds of teeth, goes to these bones, and we happen to find a couple of teeth of something else in there. And the T-Rex one, there's some bits of Triceratops in the original T-Rex quarry. And sadly, no one produced a reconstruction of Triceratops with giant fanged T-Rex teeth, and no one ever produced a reconstruction of T-Rex with a frill and giant horns on its head. But that's what the world needs. And if only they'd found enough bits of the two at the same quarry to bolt together a hideous monstrosity, because that would have been awesome, and I think we all know it.
I'm going with Iguanodon's thumb on its nose. I like that very much.
Yeah, I do like the idea of a giant reptile rhino with let's be honest, really quite little horns on its nose. Because living rhinos have way bigger horns and they're a fraction of the size. But yeah, those two would be fun.
Yeah. We did have one comment suggesting that Iguanodon's thumb might be used for picking its nose. Could it be used for picking its nose, Dave?
I don't think it can actually reach its nose, so on that basis alone, I'm going to go with no.
Oh, yeah, because it's got little arms, isn't it?
Their arms aren't that long.
I do worry about, like, dinosaurs and not being able... Animals in general who aren't able to rub their nose. It's kind of like the most important part of waking up.
Plus, I think with the picking thing, a whole part of it is surely the ability to crook the finger and really burrow it in there, and a big solid spike doesn't really do that job, so... It's
just really useful for scratching, though, a big solid spike.
Yeah, true.
Yeah. Or putting shoes on. Maybe they had to put high heels on and they had to get the... Anyway, to carry on, let's get serious now, because Eleanor, who's one of our patrons, this is her question. Rawr, 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 rawr.
Rawr, 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 rawr.
Ah, rawr. She also asks, if you could resurrect one dinosaur species a la Jurassic Park, what would best fit into contemporary ecosystems and have desirable results from its reintroduction?
I think the desirable results from reintroduction is a bit of a sticker, because I can't conceive of anything that we dump in an ecosystem and not potentially ruin it. The problem with invasive species is one of the biggest that the world is facing. It's bad enough when we move things like rats and Japanese knotweed around without, I'll just dump a dinosaur, however small. In terms of resurrecting something, obviously I'd want a big tyrannosaur or something like that, because it's not that it's an A-lister, it's that this is something that I actually work on. I've spent a lot of time thinking about and I would like to know more about, and having one of them alive would obviously really kind of help that. If I wanted something that would kind of minimally not screw everything up, I don't know, one of the relatively small or medium-sized herbivores, something like Gallimimus, one of the ornithomimids, to reintroduce into deserts. We don't have a lot of big desert taxa. We've got plenty of camels, so there's not a huge competition problem. They'd probably do all right, and they're not really screwing around with ecosystems which are already falling to bits.
Sahara's full of them now, Dave. What have you done? It's full of them. Can't go anywhere without getting stomped.
Oh, well. Nah. But yeah, that would be one of the least worst options.
I would go with the Parasaurolophus, because I reckon they could honk. And what I reckon is that if you put them in any location where they started breeding and started settling down, humans would leave that area because the honking would be so annoying.
Be horrific. That's quite possible, yeah. A few hundred of them.
Because I'm not suggesting we get like loads of carnivores and dump them everywhere to kill everybody. I just think we need to be guided into moving out of certain parts of ecosystems, and we are the most invasive species in that sense. So therefore, a big Parasaurolophus trying to sleep at night with a ha would be very difficult. We have Kath Bremer. She asks, if you could remove only one misconception about dinosaurs from everyone and never hear it mentioned again, what would it be? Or put it another way, which misconception annoys you the most?
That's a tough one, simply because, the list is so absolutely enormous. Without picking on Jurassic Park, it's just pretty much everything that's come out of that, simply because I think we talked about this when we talked about this episode just a few ago. It's become it's so iconic and so completely definitive in absolutely everyone's mind that it and everything that's ever come out of it is just fixed. And if there's one thing that comes up to me when I'm talking to kids, it's questions that start with, but in Jurassic Park, or I saw this in the film, therefore it's real. And so I know I'm not being very specific.
That's not one misconception. That is, I wish a film had never been made, and you don't wish that. So
Well, even that, just the fact that dinosaurs have been resurrected and that dinosaur DNA is totally a thing, and why aren't you working on it? That I wish could die with extreme prejudice. I remember Spielberg saying, "Oh, it's not science fiction; it's science inevitability," which I don't think was ever true. But I get what he's saying is that, we're talking near future type futurism, not Star Trek Interstellar travel futurism. But at the same time, it's a bloody film. No one watches the Avengers and go, "Oh yeah, they got time travel now. I saw it with Ant-Man."
Well, they don't have
but
time
Jurassic
travel.
Park is like, well, where's the resurrected dinosaurs? It's like, it's a film.
They don't have
It's
time
not
travel.
real. Yes.
Yeah. No, the Avengers annoys me because they basically it teaches Americans the last Avengers, and I won't say it because I don't want to ruin it for anyone. I think my misconception that I had, which I didn't realise, I thought the birds are descended from dinosaurs and weren't actually dinosaurs. Once you learn that, it blows your mind and makes feeding the ducks a whole new experience. So I think if I could just put that in people, dinosaurs did survive the KT extinction. They did, just the birds ones did. That is what I would say.
That's a good one as well.
Yeah. Okay. So both David Lowe and Spino Breaker's Back asked the same question, and they want to know if you could get a perfect skeleton, fossilised skeleton obviously, of a dinosaur with skin impressions, very fine detail, everything's there, what would it be? And why would you pick that one?
If I could have any fossil, I'd probably actually want one of the biggest pterosaurs, because the Ashdarchids that I work on, we know so little about their full anatomy, and a complete one with the crest and skin and wings and stuff would be amazing. But they're not dinosaurs, and this is more a dinosaur podcast than pterosaurs. I was
going to say.
It's probably going to be a tyrannosaur again. Again, not because it's an A-lister, but it's because there's stuff I've done a lot about. There's been paper after paper and online argument after online argument about whether or not they had scales or feathers or both or some combination of the two. I'm working on a paper on this very subject myself. There's bits of fossils out there, but they're tantalising and they're not that complete, and they're open to alternative interpretations. And there's stuff about, is there armour on the face from like these keratinous sheaths and big like rhino and buffalo like bumps on the nose and mini horns, and what colour were they, and is there camouflaged or display features, and all of that is available potentially with the perfect fossil. So that really is what I'd want. It would, a truly complete spectacular dinosaur like that of any kind would be incredible, because if you had a whole bunch of the soft tissues, we can, double check all the calculations we've made about lungs and lung spaces and muscle attachments and size of muscles and what that means for speed and stuff. It gives you what's called ground truthing, gives you a way of testing it. And that would be wonderful. But yeah, I'd want a T-Rex, obviously. Actually, I'd want a Zhuchang Tyrannus, because that's the one I named, and then suddenly it would be a lot more important than T-Rex if we had a whole one. Everyone would want to work on Zhuchang Tyrannus suddenly, so that specifically, so that Dave making
goes
me
down
more
in
important.
History. Yes.
Yep.
I would want a massive big sauropod with the skull.
Yeah.
That would be, so the whole thing, and when I say, I'm not overly fussed about which one, but just with the skull and everything attached on, and if you could get all the skin impressions and everything else, maybe, stomach contents a bit, maybe you wouldn't be able to get that. But
in that line, I'd go Diplodocus. So I think we talked about this in the Diplodocus episode, but I can't remember, because obviously that was, a year ago, but it feels like 20. So they are known to have a row of little spines down the back. So you always see that illustrated on Diplodocus, and that is actually a thing. There are fossils of Diplodocus that show they have these little spines down the back, but we don't really know how much of the back and just how big they get, and where, again, if they're coated in skin or keratin or something like that to make them much bigger. And a full-size big Diplodocus halorum, which is the really big one, which could be 30 plus meters long with all that giant bit of tail with all the spines and stuff on it as well. That would be particularly cool.
That would be. You just like spines, though. This is your, Spinosaurus coming through again, isn't it?
Yeah, and Demargosaurus and some of the others that are quite spiny.
So, James Psacoe, how do you feel, Dave, about the concept of the valid... Oh, this is where I'm going to get all the words wrong.
Do you want me to read it out?
No, I don't. James Psacoe asks, how do you feel about the concept and validity of Ornithoscelida?
Ornithoscelida.
You say Ornithoscelida, and I say Ornithoscelida. How do you feel about the concept and validity of Ornithoscelida? And what do you think of the idea of Silosaurids are ancestral to Ornithischians?
Yeah, so this is all kind of tied up together. So we have mentioned Ornithoscelida before, I'm pretty sure. So the traditional idea of dinosaur relationships is that you've got your Saurissians, which is your sauropods and your theropods, and your Ornithischians, which is basically everything else. And the Ornithoscelida hypothesis, which happened in, I want to say something like about 1918, but then it came back again just a couple of years ago with a big new analysis, suggests that in fact the sauropods are out on their own and the theropods and the Ornithischians are closest to each other. And then kind of related to that, the Coelosaurids are a group that we'd normally call dinosauromorphs. So they're close to dinosaurs, but not within dinosaurs. A whole bunch of fragmentary Triassic material, and that's been suggested to actually fill in that gap because we don't have really any truly convincing Ornithischians in the Triassic. That might explain why we can't find the Ornithischian ancestors if they're actually Coelosaurids and we've already got them. I don't know anything like enough detail about either of these hypotheses and the exact details of all the different
characters. It's asking
characters.
about what you think, Dave.
Well, I know, but it's hard to have an opinion on something you don't know in that much detail. They're both perfectly reasonable, and by that I mean lots of people suggest hypotheses all the time, which I don't think are perfectly reasonable, and obviously have big problems with them before they've even been advocated, or people have already written and pointed out some flaw in this hypothesis, and then someone advocates it again. It's like, but we literally already disproved this 40 years ago. They're perfectly possible. We've talked about this problem before. It's the bird-dinosaur transition again. When you get closer and closer and closer to the origin of a group somewhere, you have this problem that obviously they're more and more and more similar to each other, and therefore it's harder to tell them apart. And again, with dinosaurs, you then throw out 90% of the information because you don't have complete skeletons and you don't have skin and you don't have the muscles or any DNA, and you're left with a bunch of fragments and a bunch of gaps. And you're trying to work out exactly where everything goes, and they all look the same as each other, and therefore, mysteriously, it's really hard to do that, or it doesn't take much new evidence to overturn and change a hypothesis, and that's pretty much where we are with this. So the Ornithoscelida is a great case in point, because that was a big new analysis with a whole bunch of new characteristics and details, and including a whole bunch of new specimens, and they went, hang on a minute, the theropod-sauropod group isn't really very well supported, and we now get theropods plus Ornithischians. Not by much, but that's what we get. Almost inevitably, a bunch of other paleontologists kind of got together and went, that's not right. We'll have a look at your analysis and I bet we'll find a few problems with it. And that's not giant analyses, you always get these problems. It's just human error. You've tens of thousands of data points. You're going to screw something up sooner or later. But of course, if you screwed them up in exactly the wrong point, you could easily make this shift. So they went, right, we're going to have a go through. We're going to disagree about some of what you said and some of why you said it. And we think that you said this thing's shaped like this. We think it's more shaped like that. And if we change that, and their analysis basically collapsed everything. They couldn't pull sauropods from Ornithischians from theropods, really, and just got a mess. And that's pretty much where we are. I think most people, and I'd include myself in that, are sticking with the traditional interpretation for now, simply because that's what we've been using for 120 years and everyone's pretty happy with it. Not that we necessarily think it's more right or the Ornithoscelida idea is definitely wrong or fundamentally flawed, but I mean, I mention it in my lectures to my students, for example, but I'm just not constantly I'm just not going to take everything that we said for 120 years and throw it out when it might still actually be right anyway.
But it means that you have to cope with the fact that you have to look at a T-Rex and look at the Diplodocus and look at an Iguanodon and say, well, the two things which are built, they look kind of, they're on two legs and they've got little arms and they're not related at all, but the T-Rex and that Diplodocus, they're best cousins they are.
But that's always the problem with looking at things at the far end. I mean, one of the closest things to elephants is manatees. And of course that looks stupid, but of course that's because they've been evolving apart for 50 million years. And if you go back 50 million years, they didn't. Similarly, whales are closely related to hippos. But if you look at their ancestors, they've got hooves, and suddenly it's a bit more convincing. Looking at the ends of things will always drive this stuff apart. But the short version is, I'm less convinced by the Coelosaurids. I'm quite happy with the idea that Ornithoscelida could be correct. but I think everyone's waiting for just better evidence one way or the other to definitively throw it out or really well support it, and we have to really rethink the Saurischian-Ornithischian split. I know the people who both produced that paper and have written counter papers are both working on datasets. I know of independent groups who are looking at this and the origins of dinosaurs and the interrelationships, and it's just all up in the air. But we've got these new stuff coming out of New Mexico, we've got new stuff coming out of Tanzania, we've got new stuff coming out of Ecuador, and these are all really filling in some of those big gaps, and one way or the other, I think in the next 10 years it's going to pretty definitively flip, but I don't know which way.
So another one of our patrons has written in. You could be a patron too and get prioritised like this. But João Barbosa asks, why be so big if big sizes are evolutionary dead ends? Don't they know, Dave? Did the bigger dinosaurs of later periods evolve from the smaller dinosaurs of the earlier periods?
Yes and yes. So, right as you just said, evolution isn't making predictions. Evolution is selecting on what works right now. And there is a fairly fundamental idea that, on average, being bigger is good compared to other members of your species. Obviously, there's plenty of exceptions to this, but particularly when you think about large-bodied, macroscopic species, most competition is between members of your own species. Yes, elephants and giraffe and rhino and hippo, they're all competing for food with each other, but mostly elephants are competing with elephants because they want the same kind of food in the same way, and the areas that are best for them are best for elephants as well. And therefore, on average, being a little bit bigger is an advantage, because if you get into a scrap, the bigger one's going to win. You're going to be able to get more food, you need more food, you're going to be able to get that food, you're going to be able to get more water, you're going to have access to more mating opportunities because you're big and strong and sexy. If you're a female, you're probably going to have bigger, healthier babies that you can look after more easily. You can fight off predators more easily. So being big is good, and therefore natural selection will probably favour being big, and therefore you can expect to get basically size creep, where over hundreds and thousands of generations you get bigger and bigger and bigger and bigger. So that's why bigness keeps evolving.
Are you just saying this, Dave, because both you and I are over 6 foot?
No. But, and it's a huge but, when things go wrong, being big is usually a disadvantage. If you can imagine there's a minor drought and we're kind of running out of water, well, being big is still an advantage because everyone turns up at the water hole and the biggest, bolshiest one beats everyone else up and gets to drink, and so is going to survive. And therefore their big genes are going to be passed on. But if there's a massive drought, everything's dying, there's no water anywhere, the smallest, who don't need to eat very much and don't need to drink very much, are the ones who are probably going to survive. And not just individuals, entire species. If I click my fingers and caused a massive drought across all of Africa for 2 or 3 years, the elephants are doomed, the rhinos are doomed, the hippos are doomed, probably any half-decent sized animal, giraffe, mid-sized antelope, gazelle are doomed. But the mice that just need odd little leaves and a few bits of seeds, and the rabbits and the squirrels, okay, their populations will be decimated, but they'll probably be okay. And so you kill off all the big stuff, and then you've only got small stuff. But now being big is an advantage again, so bigness re-evolves.
Big mice!
So, right, and so we get these cycles of getting bigger and bigger and bigger and bigger, extinction, all the big stuff dies, you've only got small stuff, there's what we call eco space for bigger sizes, and we know that being big is an advantage, and bigness starts evolving again. And so that's what's happening. In the case of groups evolving large size multiple times, I can't think of a group that's necessarily shrunk and then got big again. There are definitely some groups that have probably shrunk. There are groups like the sauropods which have got big several times in several different groups. In the theropods, virtually every group has a giant in it sooner or later. But you don't often see giants persisting very long periods of time. I think we had this conversation with Penn, maybe it has only turned up in the extended episode, but I mentioned the Abelisaurs, which are derived from the Ceratosaurs, and they're around from the fairly early Jurassic at big sizes, and they're still big sizes in the Cretaceous. So that's probably the longest lasting group, which are big pretty much the whole time. Okay,
so Howard Wiseman. Now, we did an episode a couple of weeks ago about taxonomy, so we got to get our nerdy heads on again. So you ready? Okay, so regarding taxonomy, Regarding taxonomy, with the cladistic system, how is it not completely unworkable? The more we find out in the fossil record, or about the relationships between living species, the more distinct ranks there must be that could be defined between kingdom and species. How is it possible to come up with distinct names and Latin and Greek endings for all of these ranks, let alone names for all of the particular ones identified? Can anyone really keep track? Also, as Dave said, not Izzy, Dave said, one new fossil and a whole structure may have to change. What a nightmare. Dave's smiling at this. As a physical scientist, it seems crazy.
Yeah, so there's quite a bit to unpack there. So first of all, I'd say it's nothing like as bad as you kind of imply in the question, in the sense that, yes, occasionally we do have these flips. Let's go Ornithoscalida again. Let's say we find this new Triassic ornithischian that gives us a wealth of new data and shows that it's definitively related to the theropods and that we
so
rethink
happy.
it. It's not like we throw away all the taxonomy of all the other dinosaurs, because the theropods are completely unchanged. Inside the Ornithischia, it's completely unchanged. All those internal relationships of all those different groups and all the names we attach to them haven't changed. The only thing we're really doing is changing that one name at the base and going, we're now calling this plus this Ornithoscalida. And so it's not that awful. It's not like we constantly rearrange absolutely everything. And the groups that do flip around constantly because they're very uncertain, we know they're very uncertain. If we're sensible, though not everyone is, we don't stick a bunch of new names on them when we know those names might not hang around because we haven't sorted it out properly. And usually those fine details are really only of interest to the the few 3 or 4 people on the planet who are really focused on that area and keep up with it. So it's not that bad. And then the other thing about kind of naming the ranks, so again, we've thrown out a lot of the weird Linnaean subfamily, superfamily, hyperorder, megaorder, and all these different subdivisions because no one cares and they're pretty much meaningless. Though we do keep the names. There is Tyrannosauroideae, Tyrannosauриdae, Tyrannosaurini, going up from the most inclusive to the least inclusive group. But again, it's not like we have one of those for every single branch on the tree. We have them usually, though again, people try and name stuff because they want to do a bit of claim jumping, which I wish they wouldn't. But usually we're naming them for fairly big splits that are kind of, we think, are evolutionarily meaningful. So like the Tyrannosauroideae is all tyrannosaurs. Every single one go back 100 million years of their evolution from the really smallest little weird-headed ones to giant T-Rexes. The Tyrannosauridae is when they start getting really big and when the arms start shrinking and they get rid of a lot of the weird head crests. And the Tyrannosaurini are the absolute monstrous giants, which is just Tyrannosaurus, Tarbosaurus, Duchengtyrannus, and Daspletosaurus. And therefore, but there's a whole bunch of other little branches coming off all over the place. And we don't name every single one of them because that's awkward and confusing and they do shuffle around and it doesn't tell you anything different if this one comes first, if A and then B happens or B and then A happens. A and B are still super close to each other and they're very different from the group before and they're very different from the group afterwards. So why bother? So I agree, if, compared to someone who might is a chemist, works on elements, and it's like, well, there's 180 of them plus some isotopes, it looks horrific. But we've got 4 billion years of evolution across 1.5 million named species. You're going to get some fuzziness. Sorry.
So he's obviously works in the physical sciences, so he's either a spoilt engineer or not a quantum physicist. It doesn't...
Yeah, at least our names make sense, whereas they have flavours of quarks. Was it up, down, left, right, and what's the other one? Strange. Oh yeah, that's the obvious opposite of up, down, left, and right.
I quite
Strange.
Like that.
Thanks for that.
Yeah, you
Not
go.
front and back. No. And then they're called flavours.
Stephen Gatehouse asks, do you think we could get Dave to do a documentary series on Netflix? Oh, he'd love that. He'd love it. He says he feels there's been nothing since Walking with Dinosaurs and it's getting a bit dated. And his real question is, how seriously should we take these programmes? There seems to be a bit of quality of data issue in most productions.
Yes. So... yes, I'd love to do a Netflix series if someone wants to give me one. I've appeared on a bunch of little documentaries as a talking head, and I've been the consultant or script editor for a couple of others. I think this question probably came in before we did the episode with David Krentz, but, producers stick their finger in, directors stick their finger in, the, head of department or whoever sticks their finger in. I always recognise that to a certain degree, documentaries need to produce spectacle on screen, and that can be starkly at odds with the reality of what we know or what we think is going on. And even just, I think you get this with normal documentaries. I was just doing a lecture with my undergraduates this last week, talking about predation and hunting by big carnivores. And the thing is, the vast majority of the time, if you watch any kind of Attenborough-like documentary, the lions go on and eat the wildebeest. And if it gets away, it's described as a miraculous escape. Well, lions successfully hunt like about 20% of the time. So actually, most of the time, you should see the wildebeest escaping, but they don't really want to show that because it's not very interesting and exciting. And so it builds up this very false perspective. And similarly, I am quite happy with the idea that, Allosaurus and Ceratosaurus got into a massive fight occasionally, and a big adult T-Rex went and had a fight with a big adult Triceratops, and it was a bloody, gory fight to the death. I'm sure that happened, but it would have been an extremely rare occurrence. But they don't want to make a documentary where T-Rex walks up to a Triceratops and goes, bloody hell, he's massive. Look at the horns on that. I think I'll have a salad. And turns around and wanders off because it's not great telly. And so they don't do it. But of course, it therefore means that every single documentary has to have the big face-off and blood and gore. And of course, it just doesn't work like that. And I don't know how you fix that, because I do appreciate that you want people to tune in, and the average viewer is probably more interested than accuracy. What does annoy me, though, is that I don't think you're detracting from that if the narration says this was probably a very rare event and would only happen if...
Don't like the word probably. They don't like the word probably.
I know. And with paleontology, it's a nightmare because, of course, almost everything is based on uncertain. We do not have anything quite as definitive as they would like. So yeah, that's kind of the problem.
One thing that really annoys me about watching the lions hunt in the Serengeti is that lions are crepuscular. So the reason you see them like hunting the wildebeest during the day is they're desperate at this point because they're so hungry that they're bothering to hunt at the heat of the day when the sun's up and you can actually film them. Most of lion hunting is done when it's like twilight and dark and you can't see them, because that's ideal for hunting stuff. Yeah,
when I've been down in South Africa, I mean, that's what you get. Everyone goes out for their super early morning game drives because they know that if you're going to see lions, it's because they killed something last night, and you're going to see them this morning because they're all going to sit around and eat it for a few hours, and that's the easiest thing to do.
So we've got a non-Patreon question. He's just snuck in here, and it's from Konstantin Rybakov. Is it possible that some new piece of media influences people's views of dinosaurs the way Jurassic Park did back in the 90s? And if yes, what could it be? A TV series, a video game, a podcast? Winky face. Yes, of course, a podcast, winky face, Konstantin.
Yeah, I think I'd rule out video games because although they're extremely popular, they won't reach an older demographic. So I think it has to be either a documentary or a movie. And I think probably the movie, again, we kind of mentioned this earlier, the Jurassic Park effect. Okay, when that came out, it was, an absolute game changer. And yes, that's a series that has dragged on, and the last one's coming out this year or next year. I assume at that point, after 9 movies or 6 movies, they're probably going to take a bit of a break and expect a bit of dinosaur fatigue. And I think we can all expect a reboot in 6 or 7 years. But if they really go for it in that reboot, if they get in a production team and a director who wants to definitively make it different, or even go back to the ethos of the very first film of this is as up-to-date as we can make our dinosaurs and super cutting edge and brand new, I think that was the kind of thing that would have that influence. Because you got to remember, things like this are watched by tens of millions of people. And that's a reach that you we sure as hell not going to get on this podcast. But it's that visual, visceral thing. You go to the cinema, it's on a big screen, it's IMAX, and there's sound, and it's thrilling and engaging, and those images will stick in your mind in a way that I think even the best documentaries won't. And again, they have that rewatch value, and they have that multi-generational thing, because small kids will watch them, and even, it's not just young adults who are going, I remember when I saw Jurassic Park, I was 18, 19, something like that, but I remember my friend took his parents along because he was so thrilled by it and wanted to see it again, and he took his parents along, and I think even one of his grandparents. That's not again, video games are not going to have that reach. The podcast is not going to have that reach.
What?
So I think that kind of movie.
My dad has listened to one of these, at least. But yeah, anything that, who's to say what the future media will bring? I think the trouble with modern media now is there's very few things which everybody sees anymore. So we sort of talk about films, but even the films in the last few years, you can talk about streaming and maybe a series like Tiger King or something where everybody seems to be, it permeates the media. But it's not like in the olden days when you'd watch a TV show and there's only 4 things on television and everything got talked about.
That's what I was immediately thinking of, is the days of 4 channels, at least in the UK. And, Christmas came round and there was usually a big movie on BBC One and a big movie on ITV, out of sync with each other. And pretty much everyone watched them because it's Christmas and there's nothing else on, and it's Christmas and you've all eaten too much and you've had a fight over Monopoly. And they pick something that's fairly family friendly and big, and it,
like The Great Escape.
Right, but it often would be something like Jurassic Park,
Harry Potter.
Yeah, it's exactly that kind of film. And so that has that transgenerational reach. Again, it's harder and harder these days.
Yes, everybody's isolated, so you should go and listen to some fundamentalist Christian non-evolution podcast to balance ours out. That's Dave's twitching.
Dave's visually twitching.
Excellent. So, shall we wrap up then, or shall we just do one more question? Just one more question.
I think we can do one more, because we'd have fairly several big gaps.
Well, you see, the thing is, I think instead of asking you one of our audience's questions, I've got a question to ask you, because you put a status on Facebook. Yeah. Didn't you, Dave? Wanting to eat your own face off, didn't you, Dave? Because you missed something out of your dinosaur paper, didn't you, Dave? And it's funny to hear you hate yourself. So let's talk about that.
Yeah, so the Spinosaurus paper that was obviously our big launch episode of this series, which was it's one of the longest papers I've written. It's like 13,000 words and covers God knows how many topics and subtleties about Spinosaurus behaviour and ecology. And yeah, I realised just the other day that there was a bit, it would have been a short paragraph, but there was a bit that I should have written, which I think explains a certain amount of Spinosaurus' anatomy and behaviour, and fulfills a prediction I myself made in one of my own papers about 10 years ago, and therefore doesn't necessarily exactly prove me right, but is quite a nice additional line of evidence to support that hypothesis, and was something I'd been speaking to a friend of mine about, a paleoartist called Brian Eng, admittedly on Dilophosaurus rather than Spinosaurus, but the same fundamental issue discussed with Brian while writing the Spinosaurus paper. And for some reason, it didn't occur to me until 2 or 3 days ago, where out of absolutely nowhere,
you were making toast or something.
I was playing a game on my computer, and my brain went dunk, and you're like, "Oh my god, why didn't I do that?"
So what is it, Dave? What is this?
So what is it? Yes, yeah. I knew we were going to get around to that. But what is it actually? So, about 10 years ago, I wrote a paper about dinosaur sexual selection and ornaments and signals, so all the crests and spines and stuff over the eyes and off the back of the head and
floofiness, fancy,
all of that stuff. And one point I made is that, in general, these kinds of features are way bigger in herbivores than carnivores. And the logic for that was, these things obviously change your appearance, particularly if you make them brightly coloured. They really change your appearance. Now, herbivores obviously want to hide from carnivores, but to a degree they can't. They have to spend very large periods of the day eating or walking around looking for food where they're not paying attention. One side effect of this is herbivores often live in really big groups, and we know that lots of dinosaurs lived in really big groups, and therefore you're even less well hidden because now there's 100 of you and you all weigh 5 tons. And therefore, actually, growing a giant Parasaurolophus horn on your head and making it bright red and honking isn't really the difference between being spotted by a Tyrannosaur and not. And since it therefore might get you the ladies or get you to do what you want, you're going to go for it. That's not true of the carnivores. The difference between them being able to sneak up on that herd and not might be the difference between having a really big red crest and having a mid-sized duller crest. So in other words, there's this evolutionary competition and trade-off basically between showing off and being sexy and being seen by your next meal. And therefore theropods may have had much smaller crests on average than herbivores. And this, where this is relevant to Spinosaurus is we advocate myself and Tom Holtz advocate in the paper that the big spine, the big sail on the back and the sail on the tail are probably some sign of sexually selected signal. Actually, Spinosaurus has a little crest between its eyes as well. Now, that would seem to counter our hypothesis, except what I'm saying is we think Spinosaurus is being a heron. It's standing around knee-deep in water with just its nose sitting under the surface, and then it's grabbing after fish. Fish aren't worried about a little crest on the back of its head or the sail on its back or the sail on its tail. They can't even see it. It's out of the water, and it's surely not in their perception that that might have anything to do with the spiky bit 5 yards away on the end that's grabbing them out. In other words, Spinosaurus is free of that pressure of having to worry about its prey seeing it coming, and therefore sexual selection can run rampant on the body where it's no longer a problem for it. And that's what I should have put in the paper and didn't. And I'm really annoyed about it. And it's the kind of thing that I absolutely should have included because it therefore you can make a prediction about other things.
Gazump Dave and put out a dinosaur paper about Spinosaurus.
No, that would be scientific malpractice. And if I find out that someone does, I will come down on them. I would say, though, because it's relevant, and just to drag this on a bit, that is a problem. So one thing I do is I try and avoid reading blogs by not necessarily colleagues of mine, but like random people, for want of a better phrase. I know some comic book artists, and I know some people like David Krentz and some people who are involved in...
Some comedians, some comedians as well.
You might, yes, but you might have the same thing, and you'll see that comic book artists are always being asked by people, well, there are nice guys on Twitter who spend their time, tweeting out and answering questions and stuff, and someone goes, cool, I've got a script for a comic, or I've got a character I've designed, can you take a look at it? Or filmmakers, can you take a look at my script? And the answer is always no, under any circumstances can I look at that. Because if I'm ever involved in a film that has any elements in common with your script, you might turn around and sue the studio and go, I showed him my script and he's nicked that character design, even if it's just he had a star on his belt or he fell out of a tree and that's what gave him his super, or whatever else, because it's impossible to prove either way and immediately turns into a giant legal mire. And we kind of have the same problem.
You have it with stand-up comedy where people accuse of stealing each other's jokes.
Yeah, I'm sure. And there was one not too long ago about some joke about Trump, or it may have even dated back to Obama. And it's the same thing, like 3 or 4 late night Tonight Show equivalents all made the joke that was basically the same as someone's joke on Twitter, and the guy tried to sue them. And their argument was, this was low-hanging fruit. He made a double entendre, so we made a knob gag out of it, or the equivalent. I don't know if we can have to edit that out. But it was an obvious joke to make based on what he'd said. We're not ripping you off. We all came up with the same joke the same way. Yeah. And we have the same problem in science. There's hundreds of people writing papers about dinosaurs. There's hundreds of people blogging about them. And as soon as a paper comes out, they go, oh, what about this? Or what about this? Or what about this? And I don't want to read that stuff, because I genuinely don't want someone accusing me years down the line of, you read that on my paper. I wrote that in my blog, and now you've written a paper about it and you say it's your idea. It's like, well, it was my idea. You're not the only one who's able to think about dinosaurs and work about this. I've got stuff written down on bits of paper that are 15 years old that I want to build analyses around and test and try and study. I've literally got a paper sent to me to review this week of a project I've been planning for years and not been able to do. And I probably talked to the authors of that paper about it at some point, because they're Tyrannosaur workers. But I don't think they ripped me off, because they probably had the same idea. They just got round to it before I did. But there is a problem with something like, I think this is a really specialist niche idea. And if someone goes and sticks it in a paper now, after I put it on Facebook and put it on the podcast, I will have some strong suspicions, because I didn't even think of it initially. And I'm one of very few people working on both Spinosaurus and cranial crest development in theropods. But, you know, we have had issues like that where people have accused each other of ripping off their work. I've definitely seen a paper come out using a methodology that I had spoken to the author about a year earlier and said, oh, well, I've got this data set that I'm going to analyse, and I think the way to analyse it is with this methodology because it would give us a good answer. Lo and behold, they publish a paper using that kind of methodology on a similar data set. And I cannot help but feeling that they took my idea and ran with it and didn't credit me.
Well,
but I also can't prove that they hadn't thought of it before and just didn't tell me that when we had a conversation about it.
Controversy and bitterness, and you should have put it in your paper the first time round, Dave. If somebody gazumps you, it's your own silly fault. Right.
I'm poking my tongue out. That's why she's giggling.
So we haven't got through all of our questions this episode. However, what we will do, after this episode's been out, we'll put a notice on Patreon and we'll do a live show and we'll answer the rest of your questions. So if you've still got some questions and you want to send them in, do it as soon as you hear this episode. Otherwise, it might be too late.
Yeah, we'll record that probably a couple of days after this goes out. So don't hang around.
Don't hang around. But obviously, we will be back because this is the end of the series. However, we will be back. We are hoping and thinking, assuming all of our schedules work, etc., that early June will be the time the next series will be out. So we're going to get some guests and it's going to be awesome and it'll be all dinosaur-y, knowledge-y stuff. There will be a couple of bonus episodes, hopefully, coming out, and obviously more bonus material for patrons. So go to patrons. I think it's patreon.com/terrible lizards if you want to support us, or go to terriblelizards.co.uk to find out more about us. You can find out more about me at izzy.com, ISZI.com. You can find more about Dave at
davehone.co.uk.
There you go. And it's hone, not home. Enjoy spelling Dave Hone, because that was hilarious when your paper came out and everybody science journalists cannot spell.
But it's like they don't have to spell. They can just copy it from the press release that they've read, or from the paper that I've sent them, which has my name in it.
No.
Or my email address, which has my name in it.
What was his name? Was it Dick Hontz?
There was some particularly ridiculous one, but I think it got stuck through Google Translate.
Okay.
I think it went two ways through Google Translate, because the whole thing was like a Chinglish mangled version of the press release.
My name, Izzy, occasionally gets translated to drink. So I don't know what language that is, but anyway, ladies and gentlemen, boys and girls, we'll be back soon. Until then, however,
Thank you for listening to the Terrible Lizards podcast with Izzy Lawrence and Dr. Dave Hone. This episode was only made possible thanks to our patrons on Patreon, and for listeners like you who share our content with your friends. So please spread the word on social media. You can find us on Patreon, Facebook, and at ISZI_LAWRENCE and at DAVE_HONE on Twitter. Include the hashtag Terrible Lizards. Ask us your questions via terriblelizards.co.uk, email terriblelizardspod@gmail.com. We are hoping to bring you so much more, but we can only do that if our audience continues to grow. So please like, share, and subscribe.